We're going to look at a couple of questions that incorporate prior knowledge because all that is new in today's lesson is differentiating sine and cosine. So let's look at the first question. Show that f of x equals x plus sine x is never decreasing. Now that's prior knowledge. How would you show that a function was never decreasing? Well, hopefully you remember you would need to show the gradient was greater than or equal to 0. And how do we get the gradient? From the derived function. So we would need to show that f dashed x was greater than or equal to 0 for all values of x to show that it was never decreasing. Now f dashed x, let's work out f dashed x then. F of x equals x plus sine x. F dashed x, differentiating it term by term, differentiate x and we get 1, differentiate sine x and we get cos x. So f dashed x is equal to 1 plus cos x. Now we need to show that that is greater than or equal to 0 for all values of x. 1 is a constant. Cos x is the part that can vary because cos x ranges from -1 to 1. So the minimum value of f dashed x would be the minimum value that the cosine would take. So that is 1 plus -1, which is 0. So the minimum value that f dashed x can take is 0. So f dashed x is greater than or equal to 0 for all x, and so the function is never decreasing. Let's look at a second question. Find the equation of the tangent to the curve y equals cos x at x equals pi by 6. Find the equation of the tangent. Again, prior knowledge. You know that that's a straight line. So we need a point on the line and we need the gradient. Now the point on the line is also on the curve. So we can get the point on the curve and we can get the gradient. Familiar, you should know we need to find the gradient and we need a point on the curve because that point is also on the line. Gradient we get from the derived function, so let's work that out. Now Leibniz notation this time, dy by dx is equal to differentiate cos x and you get negative sine x. So dy by dx is equal to negative sine x. This gives us another function that will give us access to the gradient. Now we want it at x equals pi by 6, so the gradient m is equal to negative sine pi by 6. So that would be negative a half. So we've got the gradient. Now we need the y coordinate of x equals pi by 6. So when x is equal to pi by 6, it's on the curve, y equals cos x. So y would equal cos pi by 6. That would be root 3 upon 2. So we have our point, pi by 6, root 3 upon 2, and we've worked out our gradient is negative a half. So now we're going to use y minus b equals m times x minus a. So let's do that. And that's us finished.